Something is coming from between the stars. Not a comet, not an asteroid. Something we have no name for yet. In 2017, the first object from outside our solar system passed through our neighborhood. It came in silence. It left in silence. We turned our telescopes toward it. We calculated its trajectory. And what we found disturbed the people who understand these things most. Something had entered our solar system, and we had almost missed it entirely. Now NASA and ESA are building something in response. Not a telescope, a trap. The object arrived from the direction of the constellation Lyra, moving at 26 kilometers per second. At an angle no object born in our solar system could have. They named it Oumuamua, a messenger from afar arriving first. And from the moment astronomers began analyzing it, something was wrong. Oumuamua was elongated to a degree never seen before, 10 times longer than it was wide. Like a cigar, or something designed to move through space. It was discovered by the Pan-STARRS telescope in Hawaii, designed to find objects that might hit us. What it found, instead, came from somewhere else entirely. The astronomers who first studied the data checked the numbers again and again, because what they were looking at should not have been possible. Then came the acceleration. As Oumuamua moved away from the sun, it sped up, by an amount no known natural mechanism could explain. Comets accelerate near the sun. Gas jets from their surface act like thrusters, but Oumuamua had no tail, no gas, no dust, nothing. It accelerated in complete silence. Every comet we have seen releases material when heated. That release creates the tail. Oumuamua had no tail, and yet it accelerated. Something pushed it, and we do not know what. Abraham Loeb, professor at Harvard University, former chair of the astronomy department, one of the most cited astrophysicists in the world. He said what most scientists would not. He published a paper suggesting the most mathematically consistent explanation was that Oumuamua was a light sail. Thin, artificial, pushed by sunlight, technology from another civilization. A light sail is not science fiction. The Planetary Society's Light Sail 2 demonstrated the concept in 2019. Exactly what Oumuamua's behavior suggested. Except we didn't build this one. The scientific community offered alternatives. Hydrogen icebergs, nitrogen ice, pancake-shaped rocks. None of them explained everything. The acceleration remained unexplained. Then came the second one, August 30th, 2019. Gennady Borisov, working with a telescope he built himself, spotted something unusual over Crimea. A retired military officer and amateur astronomer. On that August night, he found something that would put his name into history permanently. The second confirmed interstellar object. Unlike Oumuamua, Borisov had a tail. Scientists were relieved. This one seemed natural, familiar. But then they looked more closely. The chemical composition of Borisov did not match any comet in our solar system. Far more carbon monoxide than anything born here. It came from a solar system unlike ours. Borisov continued its journey out the other side, moving toward Cassiopeia, never to return, carrying its secrets into the darkness, and we could only watch it go. Astronomers calculated the statistical implications. If two objects were detected, how many are actually passing through? The answer was disturbing. Potentially thousands per year. Most too small to detect. Most too dark. Most moving through our solar system without us ever knowing. The space between stars is not empty. It is full of objects moving between solar systems. Some natural debris, and some of them possibly not. They are already here. Passing through right now, we simply cannot see them. Computer models suggest interstellar objects are far more common than anyone assumed. The Milky Way is filled with them. Some from solar systems that no longer exist. Remnants of dead worlds, traveling forever through the dark. Our solar system is a small bubble in an enormous galaxy. And through that entire vast structure, objects are moving constantly. Between systems. Between stars. Some of them heading toward us. The mathematics told scientists something important. We have been essentially blind. By the time we saw them, they were already leaving. The next one, we decided, would be different. The night sky looks empty to the human eye, but it is not empty. It is full of things moving in the dark, things that have been moving for longer than Earth has existed, and some of them are heading here. In 2019, the European Space Agency approved a mission unlike anything attempted before, designed to intercept something unknown, something not yet discovered. They called it Comet Interceptor. The European Space Operations Center in Darmstadt manages the most ambitious space missions in history. Comet Interceptor was approved here. in a building full of people who understand exactly what they are building and what it might find. One main spacecraft, Probe A, two smaller subprobes, B1 and B2. All three will separate and approach from different angles. A three-pronged analysis, the first of its kind. Probe A carries the primary instruments. It will maintain communication with Earth throughout the flyby. It will survive the encounter, or try to. It is the brain of the mission. The smaller probes are sacrificial. They will fly closer, much closer, into the debris field. They may not survive. They will transmit data in the seconds before potential destruction. Data is more important than hardware. The waiting position is the second Lagrange point. L2, 1.5 million kilometers from Earth, the same location as the James Webb Space Telescope, where Comet Interceptor will wait in the dark for however long it takes. The Vera Rubin Observatory in Chile is the other half. It will photograph the entire sky every 3 nights. It will detect interstellar objects far earlier, weeks earlier, possibly months. Enough time for Comet Interceptor to act. Vera Rubin detects a new object on an interstellar trajectory. Scientists calculate the intercept window. Comet Interceptor fires its engines. The flyby happens. The data comes back, and for the first time, we see what these things really are. The intercept trajectory will be calculated in real time. There is no pre-planned route. The navigation team will design the flight path after the target is identified, racing to meet something that is not slowing down. The window will be limited. Interstellar objects move fast. Once the object passes the sun, it will accelerate outward. The window closes within weeks. Everything must happen quickly. There is no second chance. The instruments are designed for one purpose: to understand what something is made of before it escapes forever, each asking a different question, and each capable of detecting something unexpected. The relative velocity will be enormous, potentially 70 kilometers per second, faster than any human-made object has traveled relative to a target. The flyby will last minutes at most. Every second will count. The payout could be the most important scientific data in human history. Pristine material from another solar system. Chemistry we have never seen. Answers to how planets form, how life begins, whether we are alone. The data will be transmitted to Probe A, then to Earth, traveling at the speed of light, arriving at ground stations where scientists will be waiting, reading an object that has traveled billions of years to reach us. The moment that data arrives, the world will know what Comet Interceptor found, whether it was a pristine comet or something that requires a different explanation entirely. The spacecraft will launch in 2029, and then it will wait. Here's the question the mission documentation does not answer. What if it is not a comet? What if it behaves like Oumuamua, accelerating without explanation, shaped in ways that natural processes don't produce? What then? The scientists who designed this mission are not naive. They know what Oumuamua did. They know no fully satisfying natural explanation has been published in 7 years. And they built instruments capable of detecting the unnatural. Look at Oumuamua from a different angle, not as a rock or a comet, but as what it would look like if it were a derelict probe. Old, non-functional, drifting, doing what it was built to do billions of years ago, in a civilization that may no longer exist. The galaxy is 13 billion years old. Life could have evolved, built technology, sent probes, and gone extinct long before our sun even formed. What we might be intercepting is not a message from a living civilization. It might be a remnant from a dead one, a ghost of something that was. Tabby's star dims in ways no natural explanation has accounted for. Some astronomers suggested a megastructure, a Dyson sphere under construction. They were ridiculed. But the dimming continues. The Breakthrough Listen initiative has spent hundreds of millions listening for signals. They have detected anomalies, none confirmed as artificial, but none fully explained as natural either. The search continues. In 1977, a radio telescope picked up a signal so unusual the astronomer wrote next to it, "Wow." It lasted 72 seconds. It has never been detected again. 47 years later, we still cannot explain it. The direction of the WOW signal points toward nothing remarkable. No known star, no known planet, just empty space, or what we assume is empty space, because we cannot see everything that is there. The inability to explain Oumuamua's acceleration has not gone away. Scientists have published dozens of papers, each failing to account for all observations. The acceleration remains, the silence remains, and the questions remain. Comet Interceptor will get within a few hundred kilometers, close enough to photograph individual surface features, Close enough to detect composition, close enough to measure magnetic fields, close enough to know the dust shields are engineered to survive impacts, with particles moving at tens of kilometers per second. But if the object is not natural, if it is structured, functional, active, the shields may face something different, something we have not designed for. 70 kilometers per second. At that speed, the time to collect data is measured in minutes. The instruments will take hundreds of images, thousands of measurements. A complete scientific portrait in the time it takes to watch a television program. After the flyby, the small probes will continue outward into interstellar space. There is no retrieval, no return. They will drift forever, carrying data they have already transmitted. 2 small machines launched by one civilization into the space between stars, never to be seen again. The interstellar medium is thin gas, dust, magnetic fields, occasionally something larger. Objects ejected during the violent early history of other systems, traveling for billions of years, until our sun's gravity pulled them close enough to see. If the next object is artificial, if it is moving with purpose, if it is not dead technology but something functioning, something aware, then the flyby will be the first direct contact between human-made technology and something built by another intelligence. That is the calculation nobody says out loud, but everyone in the room has made it. The Vera Rubin Observatory will change everything. Its camera has 3.2 billion pixels. It will detect objects smaller and darker and faster than anything we have found before. It is the eye that will see the next interstellar visitor before it gets close enough to threaten our ability to respond. The Milky Way contains 200 billion stars. Everyone could have launched objects during its formation. Some of that debris escapes. Some travels between stars for billions of years, and some of it comes here. The next object is already in transit. Right now, somewhere between the stars, something is moving toward our solar system. We don't know what it is. We don't know where it came from. We don't know when it will arrive. But statistically, it is out there, and Comet Interceptor will be waiting. When Vera Rubin detects the object and the trajectory is confirmed, the mission team will receive the alert. Engineers will calculate the intercept window, and Comet Interceptor, silent at L2, will receive the command to activate. Its engines will fire for the first time, and it will begin to move. The approach will be the most complex navigation ever attempted in real time. A moving target on a trajectory designed by gravity, not by human engineers. A closing speed measured in kilometers per second. A window measured in days. This is what Comet Interceptor was built for. The first images will show us the surface. The cameras will operate at full capacity, photographing whatever is there. Ice and rock and ancient chemistry, perhaps. Or something the cameras were not designed to photograph. Something that requires a different vocabulary. If the object is natural, the surface will look familiar. Dark, irregular, ancient, like Comet 67P studied by Rosetta. Except, the chemistry will be alien, from a place we will never visit. If the object is not natural, the cameras will show us something else. Geometry where there should be randomness. Regularity where chaos should exist. Material properties that match no natural composition. The instruments do not have opinions. They measure. And the measurements will speak for themselves. The data will travel back to Earth at the speed of light. And the first people who see that data will know, before anyone else on Earth, what Comet Interceptor found. In that moment, before the press release, they will know what we are dealing with. The control room will be quiet. People who spent years building this mission, staring at data from an object that traveled between the stars. The numbers will appear on the screens, and the scientists will read them, and they will understand before they say anything to anyone. The expressions on their faces will tell the world something, even before the official statement. Scientists are not good at hiding what the data says. If it is extraordinary data, it will show. It always does. After the flyby, the object will continue outward, accelerating away from the sun, leaving our solar system behind, into the space between stars, where it will travel for millions of years, or until it reaches wherever it was going. Earth from this distance looks like nothing, a pale point of reflected light, and yet from that point, we are building a machine to intercept something from another star system, a species reaching out into the dark to touch something that has traveled for billions. The next interstellar object is already moving. In the dark between stars, something is in transit, heading, by chance or by design, through the inner solar system. It does not know we exist. Or perhaps it does. Either way, it is coming. And in 2029, we will no longer be unprepared. Comet Interceptor sits at L2, silent, powered down, waiting with the patience of a machine. It does not grow tired. It does not wonder. It simply waits for the signal. The most important signal it will ever receive. The location of something from another star. In the darkness at L2, 1.5 million kilometers from Earth, a spacecraft waits, built by human hands, designed by human minds, sent to answer a question that has defined our species since we first looked up at the stars. Are we alone? Whatever is coming does not slow down. It moves through our solar system the way it has moved through space for millions of years. Indifferent, constant, unstoppable. But this time, for the first time, something will be there to meet it. From out here, Earth is a point of light, an unremarkable star, an unremarkable planet. Except that on that planet, a species decided that the unknown was worth understanding, and built something to reach for it. Comet Interceptor is ready. The trap is set. The only thing missing is the target. And the target is already on its way. We do not know its name yet. We do not know what it is. But in 2029, when it enters our solar system, we will no longer have to wonder. Something is coming from between the stars. It has been traveling for longer than Earth has existed. It does not know about us. Or perhaps it was sent precisely because of us. Comet Interceptor will be waiting, in the dark, at L2, patient and silent, like a question waiting for its answer. Whatever comes next, we will be there to see it. For the first time in history, we will not miss it.